Hello everyone, in this video we are going to learn how to sketch the gradient functions. We aim to use the features of a function and then to sketch the corresponding gradient function. For an example, we have the graph of function looks like that, and to see how do we process the graph of the gradient function, I also sketched the axis of that. Now focus on the graph of the function. The first diagram, we can see that this curve has two stationary points. One is the local maximum, another one is a point of inflection. So at first, let's see on the left-hand side of the local maximum what has happened. For this part, we can see the gradient is positive. So we have positive gradient, which means you compare to the graph of gradient function, the curve in the gradient function has a positive values, which means the curve is above the x-axis. So this means above x-axis. Sorry. And you can see that if we start from here and goes along with the curve, we meet the local maximum point. Remember that the gradient of any stationary point is 0. So we have the gradient 0 over here, which means the gradient is decreasing to 0. So we can draw the graph of the gradient function of this part. So the curve should be above x-axis, and at the point, at the x-coordinates of the local maximum, it reaches 0. So we can have the graph So we start from here. We can have the curve looks like that. So it's decreasing and reaches to 0. Right? And now let's focus on this part. We can see it has a negative gradient. Right? From here to here, it has the negative gradient. So we have the negative value of the gradient, which means it should be below x-axis in the graph of the gradient function. And let's go along this curve. We can see the gradient is decreasing, and then we can see it rise up a little bit, which means it turns to increase and reaches the point of inflection. It has the which has a gradient 0. So we can see that for this part, the gradient is decreasing. And then increasing to 0, which means the curve of the gradient function at the x coordinates of the point of the inflection here should be 0, right? And we know that it should be below x-axis, and the process is that it decreases and then increases. So we can have the curve like that. Sorry for the bad sketch. Let me sketch that. Yeah, something looks like that. Now we have the final part. So in this part we can see it has the negative gradient. Which means the curve of the gradient function below the x-axis. And also we can see that the value of the gradient is decreasing. So we can see that in here we have the tangent and another tangent, another tangent. We can see that the value of the gradient is decreasing. This we can draw the rest of the curve of the gradient function. Remember that below x-axis and the value of the gradient is decreasing. So it should be looks like that. This we have complete the graph of the gradient function of this function. So this is the y equals to f dash x. This is the graph of the gradient function. So overall, let's list a table of that. So some key features of the function. So first one is maximum and minimum point. It means that the gradient is 0. So at this point, the curve cuts, let's use another curve, cuts the x-axis. And for the point of inflection, it touches the x-axis. Remember that the gradient on the other side of the point of inflection should be the same, whether it should be negative, negative, or positive, positive. So it touches the x-axis, not the cuts the x-axis. And if the function has a positive gradient, which means the curve of the gradient function should above the x-axis. On the other side, if the curve of the function has a negative gradient, which means the curve of the gradient function should be below the x-axis. If the curve of the function has the vertical asymptotes, it does not change in the gradient function. So it's still vertical asymptotes in the graph of the gradient function. Well, for the horizontal asymptote, it has changed. So in the graph of the gradient function, the horizontal asymptote should at the x-axis. So these are the key features of the given function. And then you can use these features to sketch the corresponding gradient function. Here is the end of the video. Thank you for watching.